No, right.
Got Disciple as well, so hi Disciple.
Oh, hi Disciple. How you doing?
That's probably the correct way to pronounce it. Correct
Disciple.
me.
Yeah, I think it's Disciple. Okay, so yeah, let's get started. Um, so I am going to use codesandbox.io. If you've seen my Pixie.js video on YouTube, I use Code Sandbox there as well. For my day to day, I use Visual Studio Code, but I think Code Sandbox is quite handy for this sort of live streaming stuff. So, if you're following along, go to codesandbox.io and create an account and get ready there. If you're using Visual Studio Code, then that's absolutely fine as well. You'll be able to follow along as well. Probably if you're using Visual Studio Code, you will want to install an extension called what's it called? Live Server, and that enables you to serve up a HTML page. So if you go to your extensions tab in Visual Studio Code and search for Live Server and install that, then you should be able to follow along. Because what you can do is on your index.html page, you can right click and choose Serve Up with Live Server, and that will work nicely as well. But if you're following along with codesandbox.io, what you will want to do is come in here and just click on New Sandbox. And then you can click on Static, because we're just doing a static web page. So hopefully everyone can see this okay. Let me just make sure that OBS is recording this happily. Yeah, seems to be. Right, so with codesandbox.io, you start off with a little bit of a template. If you're in VS Code, you'll want to create an index.html page. And then you can type in HTML:5 and then tab, and Emmet will scaffold out something that looks kind of identical to this. You probably won't get this H1, but everything else will be the same. So I am going to change my title here, and let's talk about what I'm going to show. It's going to be quite a sort of quick, very basic introduction to Canvas. Now, Canvas is a great way to it's kind of the only way really to draw on a web page, and it gives you a kind of area that you can draw shapes on, and you can actually create a whole game inside that canvas. And there's various, Canvas supports different technologies, so we're just going to use what they call the sort of standard 2D context, which is kind of the most it's a kind of the standard way to draw to the canvas, the most supported in all web browsers. But there's also another way you can draw to the canvas using something called Webgl, which is a little bit more advanced, and most people don't actually use Webgl directly. They'll use a library like 3JS, or even Unity will spit out a basically a WebAssembly module that will write to canvas using Webgl. But we'll just use the standard 2D context, and you'll see what I mean in a second. So I am going to change my title here, and I am just going to call this red jumper, because we're just going to create a very simple red square that when you hit the spacebar it's going to jump in the air. So it sounds pretty simple, but actually we'll cover quite a lot of simple gaming concepts along the way, but important gaming concepts. So how's everyone doing? Let me just go back to Discord and make sure. Is everyone sort of happy following along? I guess Pope and Pals, you're not on your desktop, so perhaps this is something that you can watch the video later on and try.
We have one new person joining just a second ago, so if you can explain maybe just quickly what happened.
Yeah, sure. Okay, so that was Org, was it? Hi Org, how you doing? Oh, and Aaron as well. Hey Aaron, how's it going? Right, so we're starting off with a simple index.html page, and I'm using codesandbox.io, but you can use Visual Studio Code, and like I just explained, you can create an index.html file, and you can do HTML:5 and tab, and Emmet will scaffold out something that looks like this. Okay, so I'm going to change this h1 tag here, and I'm just going to say red jumper, save. And the good thing about codesandbox.io and also live server is that as soon as you save, you'll see your updates immediately, which is nice. And then underneath here, I'm going to create our canvas. So it is as simple as doing that. And now we have a canvas, and if I do Control S to save, the canvas is there, we just can't see it. So I'll fix that in a second. But the next thing we want to do underneath our canvas is pull in a script. So we use a script tag, and I'm just going to say source is equal to index.js, which we haven't got, but I'll create in a second. And let's finish off the script tag like that, and save that. And then in here we will just do new file, and let's create our index.js. Now I'm always a bit paranoid, so I like to just do a console log and just do hello world and save, and then I want to look at my console, and there you go, we've got a hello world in our console. So we know that we have successfully joined up our index.js script to our web page. So hopefully everyone's okay up to that point. So don't worry about these other two files, these are not needed. So if you're in Visual Studio Code, you literally only need the index.html and the index.js. This is all that we're going to worry about today. Right, so go back to my index.js, and let's get a reference to our canvas. So I can do let canvas is equal to document dot, and then I can use a query selector, which is down here, and I can just say get the first occurrence of a canvas element. And if I console log out canvas down here, and do save, you can see that we now have, let's just clear that and refresh. You can see that it's passing back our canvas element. If you want to give your canvas an ID, we could put an ID in here, and then you can use getElementById and the name of your canvas. So this really only works if you've got one instance of a canvas on your HTML page, which is the case that we've got today. Right, so we have a reference to our canvas, so we can actually make sure that our canvas is actually on our page by styling it. So I'm going to do canvas.style is equal to, and I can put in a CSS style here, so I can do border, and then I can say 1 pixel solid border. Control S to save, and now hopefully you can see that we do have a canvas on our page, and we've just drawn a border around it so we can see it. Normally you'd do a separate index.css or style.css and link that, but I'm lazy, so I can actually put a style directly on the canvas using JavaScript, which is kind of cool. Now I am going to set the size of the canvas to whatever I want, and I'm going to make mine 256, and I'm going to set the height also to 256. Again, Control S to save, and now hopefully you can see that our canvas has changed its size. Now, I did say that we want to draw a square. Let's delete this console log, we don't need this anymore. We want to draw a square on our canvas. Now, if you've done any of my other courses, you know, this is kind of the time when I'd probably go off and create some classes, or maybe a square class or something. But this is a pretty simple kind of demonstration of how to use Canvas, so I'm not going to go off and create lots of different files or anything. We'll do everything in this file, and we'll keep things pretty straightforward. So let's just use a good old JavaScript object to define what our square is going to be. So let's first of all name square correctly, and let's create a JavaScript object. So you do that with these curly brackets, and then we can define some properties. So I'm going to say that our square is 32 by 32. So we'll define 32 pixels by 32 pixels as the size. I'm going to hold an x coordinate on the square so we know where the square is, and I'm initially going to, well, actually let's just put it as 0 for the moment, and we'll do y and also put it at 0. So if you know anything about Canvas, you know that the coordinate system is probably a little bit sort of backwards to what maybe you're used to at school or college. Often your x and your y of 0 is down in this bottom left corner down here. But on Canvas it's in this top right corner. So 0, 0 is up here. So we'll see that in a second. And we're going to add a few more things to our square in a minute, but I think we're good for the moment. So how do we draw our square? Well, the first thing we need is something called a context, because as I explained earlier, there are different ways to draw to a canvas. There's the Webgl way, and there's the sort of bog standard 2D context way. So I'm going to create a 2D context here, and this enables us to actually draw on our canvas. So I'm going to say let context equal to, and then we can say canvas dot get context, and then we need to pass in 2D like that. And so now we have a context that we can use to draw on our canvas. So if we come down here, let's just draw our square. So the first thing we want to do is we want to specify a fill style. So this is where we can specify the color that we want to fill our square with. So I'm going to use a red square, so we can do hash, and it's RGB, so red, green, blue. So FF is just full red, and then we don't want a G or a B, so we just 0, 0, 0, 0, like that. And that's essentially set our fill style to red. And then we need to kind of begin drawing. So we use this function called begin path, and that's just telling the context that we're gonna start drawing our rectangle. And then now we can specify the rectangle, and actually that's pretty handy. CodeSandbox.io has kind of told us, okay, the rect method takes an x, takes a y, takes a width, and takes a height. So we're getting this from our square object. So we can say, and let's sort of do it like this, we can say square dot x, square dot y, and that's these values here, so it's 0 and 0. And then the size of our square, well, the width of our square, which is our size, and the height of our square, which is also our size. And the last thing we need to do now is tell the context that we want to fill that rect. And now if we do Control S to save, it's got rid of my formatting, but I'll live with that. And as you can see, we've got a red square in the top left corner. So like I said, 0, 0 is up here, and that's why it's drawn the square in the top left corner. Now, depending on what you're doing, you may want to have the pivot of the square, or the anchor of the square, however you want to say it, not in the top left corner. If you think about it, we've said draw the square at 0, 0. And it's kind of placed the top left corner of our square at 0, 0. And that's generally not what you want for gaming. Normally when you're moving sprites around the screen or objects around the screen, you're actually kind of generally talking about the middle of an object. So you kind of want to say, if I'm placing the square at 0, 0, you might want it to actually place the center of the square at 0, 0. So you could do that by just taking away from here the half of the width of the square. So we can do square dot size divided by 2. So taking away half the width and then save. Now you can see we're kind of centered on the X, sort of in the middle of our square. And then if we wanted to do the same with Y, we can do that as well. So we can do take away square dot size divided by 2. And now we can't see the whole of our square. It looks like a small square, but actually the rest of the square is off the canvas. Anything off the canvas doesn't get drawn. You only see the stuff that's inside the canvas that's actually gets rendered. In this particular case, because I want my square to be on the ground down here eventually, I don't actually want to anchor the Y at square sort of in the middle. I actually want to anchor it at the bottom of the square, which for platformers generally that's probably what you want to do with your characters. You probably want to anchor the bottom of your character. So what I can actually do here is take away the whole of the size of the square, and of course that makes our square disappear because yeah, the square is actually up here now. But like I said, I wanted my square to be down the bottom here. So we actually want our Y then to be canvas.height. And we want our X, I want my square to be in the middle of our canvas, so we want our X to actually be canvas dot width divided by 2. And there you go, we've got our square at the bottom of our screen. Now, as you can imagine, we kind of don't want this square to be static, we want it to jump around. And what we need to actually get that to work is we want a game loop essentially. And so we need to create our own game loop because some game engines like Unity give you a game loop. They give you an update method, and anything that you want to sort of be dynamic, you'll stick in the update method. But we don't have an update method given to us. But we have something pretty close. So let me show you what I mean by that. So if we come down here, and I'm going to create a function, and I could call it update, I could call it anything really. I'm going to call it render, and at the moment I'm just going to I'll console log out just say hi from render. Now I know that CodeSandbox.io actually hates console logging out a lot, so I'll get rid of this quite quickly, otherwise I know this will probably start to fall over. But we'll probably get away with doing this for a moment, because we're going to be calling this render method, this render function, sorry, over and over again. And how do we achieve that? Well, we use something called request animation frame. So inside our render function, we actually do request animation frame, and then we actually pass it in this render function. And weirdly, that is the kind of correct way for setting up a game loop in JavaScript. And if we do Control S, that won't actually do anything. And let's clear our console and just do a refresh. So you can see this doesn't do anything because we actually have to call render once. And then once we've called render once, it kind of kicks off our game loop. So let's do that. And like I say, things might get a little bit sluggish now, but we'll live with it hopefully. And if I do Control S, then as you can see, we are calling hi from render over and over again. You can see this number ticking up. I'm going to quickly comment that out and clear that so that CodeSandbox.io doesn't die on me. Right, so hopefully that kind of shows you how you can set up a game loop really quickly and nicely in JavaScript. Actually, it's not too bad. So we want to move all this code inside our render because we want to basically draw this square over and over again, because we're going to be moving it around in real time. So let's do that. Let's come up here and let's take all of this and we'll cut it out, and we'll come down here and we'll paste it in, and then hopefully if I save, that should have refreshed anyway. That should still work, and you can't really see anything happening here, but this square is getting painted over and over again. And let's see that in action by adding another property to our square. So if we want our square to move, then we want to give it a velocity. So we can add in here another property, and let's call this y velocity, and let's just give it maybe a velocity of 2, say. And then what we can do is every time we come into our render here, we can do square dot y is equal to square dot y take away square dot y underscore velocity. And as you can see, now we have this, maybe you didn't see it, let me refresh. We have this square going up, but it's kind of smearing the whole canvas as it goes up. And let's just slow it down. Let's call it, say, 1. And as you can see, it kind of smears our canvas as it's going up, which makes sense because we're just drawing and drawing and drawing and drawing, and this is just smearing as it goes. So how do we sort that one? Well, what we want to do is, the first thing we want to do when we come into our render function is we want to wipe the canvas clean. Which might, if you've never done anything like this before, it might seem a bit weird to over and over again just keep wiping out the canvas, but this is how you get things to dynamically render. You wipe it every frame and then you redraw everything in its new positions, and you'll see that this works quite nicely. So we'll do a context dot clear rect, and we do 0, 0, canvas dot width, canvas dot height, which basically means it's going to clear the whole of our canvas. So let's save that, and there you go. We have a kind of jumping square. It's kind of going up in the air and never coming back down again. So it's jumping in 0 gravity at the moment. So when we're doing things like this from scratch without using, you know, a game engine that has built-in physics, then we have to create our own physics. So what do we need? Well, we need gravity. We need to pull this square back down to Earth. And if you think about it, gravity is basically something that decrements the velocity. Gravity is just basically a linear acceleration, and so if we decrement the same amount every, and we'll come back to this is actually every frame, but ideally every second, then we are kind of creating our own gravity. So let me show you how that works. So I'm going to say here, apply gravity, and I said that gravity affects our square's velocity, so let's do exactly that. We'll do square dot y underscore velocity is equal to square dot y underscore velocity, and let's take away let's take away well, let's just do 1 for the moment. Let's see how that works. See, that's too much. Let's make our velocity a little bit higher to start with, and let's make it, say, 30. You can kind of see that it shoots up. Oh, there you go. That's a bit better. So you can kind of see there's kind of jumping going on there, but the glaring obvious problem is that we're shooting down through the floor. And again, you know, nothing's doing the physics for us. Nothing's telling anything that the bottom of this canvas is supposed to be a floor that should stop the square. So we need to do that. So after we've applied our gravity, let's do our floor. Where should we put it? Let's put it right here. So it's going to be the last thing that happens is the reality of the ground. So I'm going to say apply ground. So if square dot y is greater than canvas height. Now remember, things are a little bit backwards in this coordinate system. So down here is canvas height. We're going from 0 all the way up to whatever we set our canvas height to, 256. The ground is 256, and this is the good thing about setting the pivot of our square to the bottom of the square. We know that if the square is at 256, it's good, but if it's any bigger than that, then it's gone off the bottom. So we can say square y, if square y is greater than canvas dot height, then we are going to set our square dot y equal to canvas dot height, which is kind of where we started. We're setting it to canvas height here. So let's save that, and there you go. We have like a weirdly jumping square now. But I don't want to refresh the browser to get our little friend to jump in the air. I want to hit the spacebar to get our little square friend jumping in the air. So let's do that now. So we can do this up here. So what do we need to do? Well, we need to add an event listener to our document. So I didn't really explain what document was. We use it up here, but document is essentially your web page. Yeah, it's like it's a reference to our main web document. And so we can do things like add event listeners to our document, and when we're clicking in here, it will respond to certain things. So if we do document dot add event listener, and there's one that is key down, and so it will listen for any key down strokes, and it will call whatever function you specify here. So I'm going to create a handle keys function that we're going to call. Now we also want to handle the key up, because when we release our spacebar, we want to stop jumping. So we can copy the whole of that, and instead of key down, we want to listen for key up. But we can also handle that in handle keys as well. So let's write our handle keys method, and I'm going to sort of write it at the bottom here. So I will put it down here, and we'll create a function called handle keys. This creates this is passed in an event, essentially a keys event, I think. I can't remember exactly what it's called, but what that event will have on it is a keycode property. And in fact, what I'll do is I'll console log this out so you can see what that looks like. So if I Control S and I come in here and I hit the space bar, oh yeah, it's called a keyboard event. So it says here that I hit the space bar. I could check for that, but the more usual way is to check for the key code, which if we look down here, key code 32. So 32 is the corresponding key code for our space bar. So let's come in here and if e dot key code is equal to 32, then I'm going to set a boolean, which I haven't created, I'll create in a second. I'll set it to true if the type, if the e.type is equal to, and we've got a type in here, it's in here somewhere, oh yeah, key up, there you go, here's the type, so it's either key up or key down. So I'm looking for key down, and if the type is key down, then jump would be equal to true, otherwise it's going to be set to false. Now that will work as is, but I think there's probably some edge cases where jump won't get reset to false. So just to be on the safe side, I just always set this to false to start with, and that will just, I think, handle some weird edge cases. And let's set this jump variable, let's set it up here, so we'll just let's put it together with a square, so we'll do let jump equal to false, like so. Click save. And obviously that's not doing anything yet because I'm not actually doing anything with this jump yet. So we only want to jump let's put that this code in here. We only want to jump when we hit the space bar. So we can do if jump, then we want to set our square's velocity equal to well, what am I setting it initially to here? 20. But let's create a jump speed. And we'll say 20. And this is our initial jump. And this is our jumps that are done by our spacebar. Now, as you can see, I can hit the spacebar while our square is in midair, and essentially do double, triple, quadruple jumps. So the way this is normally handled is, first of all, let's get rid of that initial jump. So we'll just have that as 0. So we only want to jump when we do the spacebar. So that sorts that out. So basically, we want to only be able to jump when we're on the ground. Now, of course, in your games, you might want to do double jumps and things like that. So that might not always be the case, but for this demo purpose, we will just say that we only want to jump when we're on the ground. So let's hold the concept of grounded on our square. So we'll say grounded is initially equal to true because we're starting on the ground. And we can only jump when square is grounded and jump. So only when this is true, and then this is a Boolean and, so when this is true and this is true, this whole thing is true, and it will come in here. If any one of these is false, then we'll never get in here. So if we save that, we can now jump. But grounded is never getting set to false. So in here, as soon as we jump, we want to set our square grounded to false because we're not on the ground anymore because we've just initialized a jump. So now, but if I try and jump again, we're not ever resetting grounded now to true. So when are we grounded? Well, we're grounded when we hit the stark reality of hitting the ground. So let's just copy that and come down to apply ground, and we are grounded when we hit the ground. Simple as that. Now you gotta jump in square. Pretty cool. Now I could leave it there because we're kind of good, but we're not really. So there's one thing wrong with this, and just gonna just double check if everyone's kind of happy. Still got a couple of people hanging in here, so hi Aaron, hi Org. I'm going to just carry on for a few more minutes and just address the frame rate issue that we've now got in our code. So what's happening here is this render function is getting called over and over and over again, and we don't really know how quickly this is getting called. It's going to try, I think, to aim for a certain frame rate, but I can't off the top of my head remember exactly what it's trying to do. But the general idea is we don't know. So we actually, at the moment, we're basically doing all this every time we come in here, no matter what. And so all this movement is happening at sort of each frame. So we might be, moving at 2 pixels a frame. And really, we don't want to be doing that. We want to be moving at 2 pixels a second. Time is our constant, except for if you get into relativity. But in general, time is our constant. and that's how we should be dealing with things. We shouldn't be jumping quicker or higher on a fast machine and on a slow machine, things being different. It's a big no-no, and even some of the early games suffered from this. So we do have something that helps us here. Now render does get sent in essentially a timestamp, and we can compare this timestamp to the previous timestamp and work out how fast or how quickly each of our frames, the sort of gap, the time gap between each frame, and we call that delta time. I'm probably not explaining it very well. I think I've got a video actually that I was told I explained it really well in, so I will probably link to that because I'm a bit tired and I can't quite explain this very well. But essentially, from our timestamp and the previous timestamp that we'll keep, we can create a delta time, and we can use that delta time to make sure that we are moving things according to time and not according to an arbitrary frame. So let's do that, and then I think we will call it a day. So at the top here, I'm going to create something called delta. Now I found that timestamp is kind of undefined initially, so we're going to have to do some checking here. So if timestamp is undefined, or start is undefined, then I'm going to set delta to 0. Otherwise, I'm going to set delta, like I mentioned, to timestamp takeaway. I don't think I've called this right really. Call it start, but it's really last timestamp. I'll keep it the way it is. And then this is in milliseconds. I think a timestamp's in. It's going to be milliseconds, so we want to divide it by 1,000. So we're getting fractions of a second. That's wrong, isn't it? Delta equal to. And let's just come up here and define start. So we'll define start here. Let's start equal to 0. And at the same time, let's create our gravity because we're just sort of hard coding this in. Now I did this earlier. As soon as you start messing around with delta time, our jump speeds are all going to be wrong. So I'm just going to specify a number that I hopefully will work. Gravity of 980, jump speed of 400. I think we're good there. And then now we want to multiply everything that we're kind of updating by well, everything that we're kind of updating on every frame. So I think we can just get away with immediately setting our velocity to jump speed, but this gravity needs to be multiplied by our delta. So we want to do square, take away not 1 but gravity multiplied by delta. And then our velocity also wants to be multiplied by delta as well. And I think we're good everywhere else. Let's just save that. And that's not happy because we have got to, right at the end, set, and I shouldn't have called it start, I should have called it last timestamp, but yeah, let's just live with it, like so. Let's see. And there you go. So we should now have a proper jumping red cube. And I'm kind of boiling up in here and a bit tired, so I think I'm going to keep it at that. But you know, I hope that that's a pretty good introduction to Canvas. Obviously you have to do more boilerplate, you have to do more work, and so but I think it's good to know all this stuff, because if you're using something like Pixie.js and Phaser, this is the sort of stuff that these frameworks are doing behind the scenes for you. Definitely Phaser is anyway. So I'm going to call it a night. I'm really happy that you guys stuck around. I will post the video up to YouTube and throw a link in the video channel. And yeah, Aaron, I can put a link into the GitHub as well. I've already got it up on GitHub, so I can throw that. No problem whatsoever.
Thank you, Morgan.
Thanks, Anna. Thanks, Aaron. Thanks, Org. Hopefully see you all soon. Have a good week.
You too.